Okay, in simplifying this expression, we're going to be assuming non-zero denominators, which means we're not going to have to worry about stating restrictions. As I go through simplifying the expression, I'm going to first need a common denominator since I am adding fractions. So there's no addition and subtraction on the bottom, which means these are monomials in the denominators. So I'm going to look at the numbers separately here. So the least common multiple between 4 and 6, or in other words, the smallest number that both 4 and 6 can go into, is 12. For the variables, I'm going to take each variable factor I see to the highest power I see it in a single fraction. So I see an x variable, and the highest power of it I see is 3. I also see a y variable. The highest power I see of y is y to the third. So this will be my common denominator. Now that I have my common denominator, I'm going to go ahead and set things up from there. We are adding. My original top was 1 and 3. My common denominator is 12x to the third and y to the third. So I'm going to write it underneath both fractions. Now, I can't just change the bottom of this fraction just because I want to. I have to balance things out. So in order to balance it out, whatever we multiply to go from the original denominator to the new denominator on the bottom, we also have to multiply it by it on the top, which is essentially just multiplying by 1. So what to multiply to go from 4 to 12? Well, we would multiply by 3. And we had x to the third. We still have x to the third, so the x's don't change. But it might be hard to see because I kind of wrote over it. But for the y's, we went from y to the first to y to the third, so we need 2 extra y's. For the second fraction, we went from having 6x squared y cubed to 12x cubed y cubed. So number-wise, to go from 6 to 12, we need to multiply by 2. And for the variables, to get to x to the third, we need to multiply x to the first, because we already had 2 of them. Y went from y to the third to y to the third, so we don't need any more y's. So I've balanced out my common denominator. The next thing I'm going to do is write it as a single fraction. I could start to simplify here. I'm going to choose not to, just because there's some mistakes that people tend to make with addition and subtraction. So I'm just going to write it out as is. Specifically, the mistakes happen with subtraction. So I'm just going to write it out as is, and then I'll start to simplify after writing it as one fraction. Okay, so it's now one fraction. I'm going to go ahead and multiply and simplify the top here. So 1 times 3y squared is 3y squared. And 3 times 2x is 6x. Over my common denominator, which is still 12x to the third, y to the third. We should try to simplify the top further, combining like terms, but there are no like terms on top. So the last thing we do for fractions after adding them is we have to try to reduce the fraction, which will mean we have to try to factor and cancel. There is a factor of 3 that can go into both terms on top as a common monomial. So I'll pull out the 3, which will give me y squared plus 2x over 12x to the third, y to the third. And then just to try to reduce it, the only thing I can actually do is we have a numerical factor on top and numerical factor on the bottom. 3 goes into both of our numerical factors, so we'll divide them both by 3, turning this into a 1 and the 12 into a 4. So on top, we'll just really have y squared plus 2x. Multiplying by 1 doesn't change it. And then on the bottom, we'll have 4x to the third, y to the third. Okay, in this example, we're going to be simplifying the expression while assuming non-zero denominators, which means we're not going to be stating the restrictions for this problem. So as I go and do this, I'm going to start by doing my common denominator here. So I'm just going to figure it out off to the side. And in order to find the common denominator, sometimes we have to factor the denominators, but neither of our denominators can be factored. So for our common denominator, we'll take each factor we see to the highest power we see it in a single expression. Well, because x and 2 are connected by addition, they are a single factor. And then on the other one, I just have x on the bottom, so it is its own factor. So my common denominator needs each factor I see, which would be x and x plus 2. So that's going to be my common denominator. Now that I have my common denominator, we have our original 4 and our original 5. My common denominator is x times x plus 2. So I can't just change the bottom just because I need a common denominator. I have to balance things out. There has to be a reason why I'm able to change the bottom. So if I change the bottom, I have to balance it out by changing the top. Well, originally I had x plus 2. Now I have x times x plus 2. So if I multiply the bottom by something, I also have to multiply the top of the fraction by something to balance it out. So the new factor in the bottom is x, so I need to multiply the top by x as well. And in the second fraction, the new factor is x plus 2, so I need to multiply the top by x plus 2. Now the next thing I'm going to do is write it as a single fraction. So we'll have 4x minus 5 times x plus 2. I know I could start simplifying it as I do this. However, there's oftentimes a mistake people will make when it comes to the subtraction problems. So I usually just recommend writing it as a single fraction first. Now that I have it as a single fraction, I just have to simplify the top. And the mistake people usually make with subtraction is they forget to distribute the minus sign through as they're distributing out and doing the multiplication with that second fraction. So as I go through and do this, I have my 4x, and I have to distribute negative 5 through, making it negative 5x minus 10 over my common denominator of x times x plus 2. I'm going to continue to simplify my numerator, combining my like terms. 4x minus 5x is negative 1x minus 10 over my common denominator still. And now that I've simplified my numerator, I just have to see if I can factor and cancel anything. I can factor here. There is a common monomial. Negative 1 goes into both terms, so I can pull out a negative 1, making it x plus 10 instead over x times x plus 2. But that doesn't really get us anywhere. So there's a couple acceptable answers for the final version of this problem because nothing cancels. Here's just some acceptable variations on the answer. The first one is where we don't factor the negative 1 out. The second one is where we do. Most of the time, either of these would be acceptable as final answers. But we can also distribute at the bottom, or we could factor out the negative 1 like we did here, and then just move that negative sign out in front of the fraction so that it's neither up above the fraction bar or down below the fraction bar. These are all different variations, and there's probably more variations you could think of, but they're all acceptable. Just be aware of them for like multiple choice type of questions. Okay, in this example, we are doing another simplifying with addition of fractions. So we're going to, again, be assuming non-zero denominators. So we're going to start off by finding our common denominator since we actually don't have one on this. And it's already factored for us. So we're going to just take each factor we see to the highest power we see it. So we see two factors in the bottom of the fraction. We see x plus 3 as one of the factors. I also see an x minus 3. However, x plus 3 is squared in one of the fractions, so I need x plus 3 squared as one of my part of my common denominator. Now that I have my common denominator figured out, I'm going to go ahead and start trying to balance out my equation or my expression. So I have my common denominator underneath both fractions. The original numerators were 3 and 2. The first fraction, to balance out what I changed, I went from x plus 3 squared to x plus 3 squared times x minus 3. So the new factor on the bottom is x minus 3. So I have to multiply the top by that as well. The second fraction, I went from x plus 3, x minus 3 to x plus 3 squared, x minus 3. So the new factor here is we have a second x plus 3. So I need to multiply the top by x plus 3. Now that we've balanced our common denominator, I'm going to write it as one fraction. And again, I could start distributing here. It's just a preference because of subtraction problems that I wait until after I write it as one fraction to start simplifying the numerator. So we have our common denominator just coming down. Okay. Now that I have as one fraction, I'm just going to worry about simplifying the top. So I will distribute my 3 through, 3x minus 9, and distribute the positive 2 through, so plus 2x plus 6. Usually you'll keep the bottom undistributed because we'll have to see if we can reduce the fraction later. So we're not going to distribute anything out down there. But I'll continue to simplify my numerator, combining my like terms. So we have the 3x and the 2x, which will make 5x, and my negative 9 and positive 6, which will make negative 3. And this is still over my common denominator of x plus 3 squared and x minus 3. The final thing we need to do is check to see if we can factor and cancel. The bottom is already factored, but the top we can't factor. Therefore, we can't really do anything else with this. And this is the simplified expression. Okay, in this example, we're going to be simplifying the expression and assuming non-zero denominators that we don't have to worry about the restrictions. We need to start off by finding a common denominator because we are adding fractions. So our common denominator, well, this time our denominators aren't necessarily factored. So we need to make sure our denominators are factored before we can actually find it. 4x squared is a monomial, so it is already factored in terms of polynomial factoring. X squared minus 3x, however, can be factored. There's a common monomial in both terms, so we have to factor that out, leaving us with x minus 3. So this is the factored version, x times x minus 3. Now I'm ready to find my common denominator. So for my common denominator, I take each factor I see to the highest power I see it in a single term. Well, I do have a numerical factor this time, 4. The other fraction doesn't have a numerical factor, so I don't have to worry about finding a common multiple between the numerical factors. I also see a factor of x. I see a factor of x in both expressions, therefore I'm going to need an x. And the highest power of x I have is x squared, so I need 4x squared as my part of my common denominator. And lastly, I also see the x minus 3 as a factor in the denominator, so I need to include that in my common denominator as well. So we have our common denominator of 4x squared times x minus 3. So we'll place that in the bottom of each of our fraction bars. And our original top was 5 and 3. We can't just change the bottom just because we need a common denominator. We have to balance it out. So the first fraction goes from having 4x squared to now having 4x squared times x minus 3. So the new factor that we multiplied the bottom by is x minus 3. So we have to do the same on the top. The second fraction, we went from having x times x minus 3 in the factored form to having 4x squared times x minus 3. Well, the x minus 3's are still there. What's changed is now we have a factor of 4, and we went from having x to the first to now having x to the second. So I need an extra x. So I've now balanced out my common denominator. So I'm going to go ahead and write it as one fraction before I try to simplify the top. Over my common denominator of 4x squared times x minus 3. Now I just have to simplify my top and possibly factor to reduce the fraction. So I'll distribute through, so we have 5x minus 15. And then 3 times 4x is positive 12x there. Over my common denominator, which is currently not changing. I'm going to continue to combine like terms here. I do have two like terms. 5x and 12x makes 17x minus 15 over my common denominator of 4x squared times x minus 3. To finish it, we should try to factor and cancel. The bottom's already factored, so we just tried to factor the top. But since there's no exponent, the only thing we could factor is a monomial, but nothing goes into both terms that would get us anywhere. So here is our final answer. In this example, we're going to be simplifying an expression. We're going to again assume non-zero denominators. In order to do it, we're going to need to first find our common denominator. But before we can find a common denominator, we need to make sure our denominators are in factored form. X minus 2, there's no exponent and no common monomial, so we can't factor x minus 2. However, x squared minus 4, well, it doesn't have a common monomial. Both terms are perfect squares, and there is a subtraction sign between the two terms. So it follows the a squared minus b squared pattern, which means the factors are x plus 2 and x minus 2. Now for my common denominator, I'm going to take each factor I see in the denominators to the highest power I see it in a single fraction. So I see two factors in my denominators. I see the x plus 2, and I also see an x minus 2, which is occurring in both fractions, but since it only occurs once in each fraction, we don't need an exponent with it. We only need it one time, so we don't need it squared since it doesn't occur more than once in a single fraction. So there's my common denominator. I'm going to go ahead and write it underneath each of my new fraction bars so that I can begin balancing it out. The original top was x and 8, and we can't just change the bottom of the fraction just because we need to for the common denominator. So we're going to have to balance things out. So what changes from the x minus 2 to having x plus 2 and x minus 2? Well, a new factor is the x plus 2. So I need to multiply by x plus 2 on the top as well. In the second fraction, to go from x plus 2, x minus 2, to x plus 2, x minus 2, there is no new factor. Actually, we have both x plus 2 and x minus 2. So because we have the same denominator from when we started to the new one, when we found our common denominator, we actually don't need anything up here to balance it out. Cool, now we're ready to write it as a single fraction. X times x plus 2 minus 8 coming along, and then of course our common denominator, x plus 2, x minus 2. Now we just need to go through and simplify the top and then possibly factor and cancel. So I'll distribute my x through, giving me x squared plus 2x minus 8 over my common denominator, x plus 2, x minus 2. We do need to check to see if I can factor the top. The bottom's already factored, so I'm going to go ahead and multiply my first and last, giving me negative 8x squared. The combination that multiplies to be negative 8 and adds to be positive 2 is negative 2 and positive 4. Since there is no leading coefficient, we can jump straight to the factors, which are x minus 2 and x plus 4. Over the common denominator, x plus 2 and x minus 2. This time we actually do have something that can cancel, so it's a good thing we did try to factor. The x minus 2 that occurs in top and in the bottom can cancel out, leaving us with our final answer being x plus 4 over x plus 2. Okay, in this one we're going to be simplifying expression and assuming non-zero denominators. So since we're adding fractions, and yes, this first thing is a fraction, because you can always write it as over 1. So we are adding fractions, and in order to add fractions, we're going to need to find a common denominator. For rational expressions, we do need to make sure the denominators are factored first. 1 is already factored, and 3x minus 5, there's no common monomial and no exponent, so it's already factored as well. For a common denominator, we'll take each factor we see in the bottom to the highest power we see it. So I see 1 in the bottom. And I also see 3x minus 5 in the bottom. I know that 3x is connected by multiplication. However, it's also connected to the 5 by addition and subtraction. which means it's all one factor based on the order of operations. So 3x minus 5 needs to be included in the common denominator. Now I have 1 times 3x minus 5. The 1 isn't necessary here because 1 times 3x minus 5 is just 3x minus 5. So our common denominator, in short, is just 3x minus 5. Just like previous, I'm going to go ahead and balance out my common denominator. Should be 3x minus 5 on the bottom of both fractions. The first fraction originally has x squared on top, and the second one originally has 2x on top. To go from the original bottom to the new bottom, to turn 1 into 3x minus 5, we just multiply by 3x minus 5. And to turn it 3x minus 5 into 3x minus 5, we don't multiply by anything. Or you can say you multiply by 1. Anyways, we're going to write it as one fraction now. So we have x squared times 3x minus 5 plus our 2x from the second fraction over our common denominator of 3x minus 5. We cannot cancel things out until we simplify the top. So we're going to distribute it out. Giving me 3x to the third minus 5x squared plus 2x over the common denominator of 3x minus 5. I should try to factor and cancel. So as I factor this top, or try to factor the top, I know there's a factor of x that comes out of all the terms. So we'll have 3x squared minus 5x plus 2. It's at this point that I realized from the rational root theorem from the previous unit that we aren't going to be able to cancel anything. So factoring further is kind of pointless. Since this requires a 5 in the last term, we would need a factor of 5, not necessarily a 5, in the last term of the stuff on the top. So we're not going to be able to cancel anything, but if you don't believe me, just going through, multiplying it to get 6x squared, multiplying first and last. Combination that adds to be the middle term is -2 and -3. Shortcut does not work because the leading coefficient is 3. So we're going to have 3x squared minus 2x, doing all of the grouping steps, minus 3x plus 2. Let's see, the thing that goes into both terms, monomial, is x, 3x minus 2. And in the second grouping, it would be a -1, giving us 3x minus 2. So overall, if I factor the top, I will have the x monomial that I pulled out earlier. I'll have 3x minus 2 as one of my factors. And I will have x minus 1 as my other factor. On the bottom, all I have is that common denominator that was carried throughout the problem, 3x minus 5. So you can see that nothing here cancels. So as far as acceptable answers, both of these would be acceptable answers. But you should still try to factor until you've eliminated the possibility that things can cancel and reduce. Okay, in this example, it's a little bit more complicated. We have multiple operations going on. It's important to identify what's going on first. So I do see this fraction on top of the fraction bar, so I'm going to focus on just identifying some things there. I see that this middle fraction bar here is longer. So I know that this on top, the 4 over x minus 1, is going to be one fraction, and the 2 over x minus 1 is also going to be a fraction. When we're simplifying expressions, we want to follow order of operations. So please excuse my dear Aunt Sally. Parentheses, we do have parentheses like the implied parentheses around x minus 1 or the implied parentheses around these fractions. However, we can't actually simplify anything inside the parentheses. Next, exponents. Again, there are no exponents. Even if there was, we probably couldn't actually simplify those. And we usually want to factor if we see an exponent anyways. Next, we're going to handle multiplication and division. So I have two fractions connected by a division. And then I have this large fraction connected by the addition. So I have to handle the division part of this first. The way we handle division is we do keep, change, flip, then we follow multiplication steps. So we're going to do keep, change, flip 4 over x minus 1, change it to multiplication, and then flip it, turning it into the reciprocal of x minus 1 over 2. My other fraction is just going to come along for the ride, plus 3 over x minus 1. I'm going to continue to focus on the multiplication division part of it. For multiplication division steps, you factor everything, then cancel, but everything's actually already factored for us, so I just have to cancel and reduce. Our x minus 1s can cancel out, and 4 and 2 can reduce to a 1 and a 2, resulting in us having 2 over 1, or just 2, plus 3 over x minus 1. So multiplication division has been handled. Now we're going to have to take care of the addition and subtraction steps. For addition and subtraction, we need a common denominator. So 2 as a fraction is 2 over 1. And for my common denominator, I need each factor we see to the highest power we see it. Both denominators are actually already factored for us. So my common denominator is going to need x minus 1. So I'll go ahead and set up 2 fraction bars with x minus 1 in the bottom of each denominator. The original top is 2 and 3. To go from 1 to x minus 1, remember we can't just put x minus or minus x. That's something I see quite often actually. We have to multiply by something to turn 1 into x minus 1, and what we multiply by is x minus 1. And to go from x minus 1 to x minus 1, we actually don't need anything there. We'll write it as one fraction, so 2 times x minus 1 plus 3 over the common denominator of x minus 1. And now we just have to simplify the top. Distributing by 2, giving me 2x minus 2, plus 3 coming along for the ride, for x minus 1. Combining like terms, so 2x plus 1 over x minus 1. We should try to factor and cancel, but we can't actually factor the numerator nor the denominator, so this is all we can actually do, and here's our final answer. Okay, in this example, we're going to be simplifying the expression. Now we have a complex fraction here with fractions on top of fractions, with operations between fractions, so we have to figure out where to start. Now I see the largest long fraction bar, so I know that that is the middle, which means the stuff on top is grouped together. There's an implied set of parentheses, and the stuff on the bottom is grouped together as well. So as we go through doing steps with simplifying expressions, we go through order of operations. Please excuse my dear Aunt Sally. So parentheses, now there's actually a lot of parentheses going on here, like this set right there, which is implied, which we can't do anything with, and the set that's around the x squared minus 1, which again, we can't do anything with. However, there is one set of parentheses I can actually do stuff with, and that is this set right up here. Because the years are connected by addition, we can actually write them as one fraction first. And in order to deal with the multiplication division, we will have to combine them to one fraction before we can do keep, change, flip. So I'm going to go ahead and deal with that. So I need a common denominator for the top. That common denominator is going to be x times x minus 1. Now, writing it out, we have x times x minus 1 on the bottom of both of those fractions that are on top. 1 and 1's there originally, over our x squared minus 1, that's not changing. We can't change the bottom, however, of our fractions without balancing it out. So the first fraction went from x to x times x minus 1. So we need x minus 1 there. And we went from having x minus 1 to having x times x minus 1. So we need to multiply by x. So now I'm going to go ahead and write the top fractions as a single fraction, making it 1 times x minus 1 plus 1x over the common denominator x times x minus 1. And this is further over our x squared minus 1. Simplifying the top, distributing the 1 through really isn't going to change anything, so I'm actually just going to erase the parentheses. I did write them there because of if it's subtraction, we'll have to distribute a negative 1, but that's not the case. Since there's no minus 1 in front of the parentheses, it was just a 1 there. So now we'll just combine like terms there. So we have x and 1x, which is going to make 2x minus 1 over that common denominator of x times x minus 1, which is furthermore over our x squared minus 1. We have done the parentheses. Exponent-wise, there is an exponent, but we can't actually simplify x squared, so exponents are off the table. Now we're to multiplication and division. So we have this keep, change, flip that we can do, and then do the multiplication steps. So on the bottom, to help us out, it is x squared minus 1. So we're going to place it over 1. Since there is no fraction, we're going to write it as a fraction so that we can appropriately do keep, change, flip. So I'm going to keep my first fraction, 2x minus 1, over x times x minus 1. I'm going to change it to multiplication, and then I'm going to flip that bottom fraction, making it 1 over x squared minus 1. I'm going to have to factor my denominators. Actually, I'm going to have to factor everything because it's multiplication, but the only thing that I can factor is that second denominator. And since both terms are perfect squares, the factors are x plus 1 and x minus 1. And with this one, nothing actually cancels, which is a little sad. So the most we can actually do is just write it as one fraction, 2x minus 1 over x times x plus 1 times x minus 1 squared. Since nothing actually cancels, it is a little bit messier than what I would have liked, but it is what it is. There is, however, a second method to do this from the beginning, so I'm going to go over that quickly here. Okay, method 2 starts off in very similar fashion. We figure out that we have to start by dealing with this first, getting rid of the fraction on top of the fraction. And in order to do that, we have to have the common denominator or a common multiple. Now, what's different about this is how we actually use that common denominator. Instead of combining these two fractions as a single fraction, this involves us multiplying the top expression, this one up here, by x times x minus 1, and multiplying the bottom by the same thing so that we balance it out. When we do this, we'll distribute the x times x minus 1 to each of the two terms up top. The bottom, in some cases, you may need to distribute. In other cases, you might need to leave it alone. But on top, we will distribute through, giving us 1x times x minus 1 over x plus 1 times x minus 1 over x minus 1. So I just distributed our common denominator through the top here. Then on bottom, I'm actually just going to leave it alone. X squared minus 1 x times x minus 1. So I'm just going to rewrite that in a different order though, putting the x out in front here. I'm going to continue to deal with the top, focusing on the top. The x's here will cancel out in this first fraction. And then the second fraction, the x minus 1s will cancel out, leaving us with 1 times x minus 1. In other words, just x minus 1. I think I'll color code that a little bit nicer. So we have 1 times x minus 1, which is just x minus 1. And in the other fraction, we just have the plus 1x left over. In other words, plus x. Still over my common denominator of x times x squared minus 1 times x minus 1. If we combine like terms now, we have x and x, which will make 2x minus 1 over that common denominator of x times x squared minus 1 times x minus 1. Now, in order to finish this, we do still have to check to see if we can factor and cancel. We might be able to factor. The bottom we can factor x squared minus 1, which factors into x plus 1 and x minus 1. However, nothing cancels. So just rewriting it as in the same format as our answer with method 1, you can see that we have the x plus 1, and the x minus 1 squared still on the bottom. But this is just an alternative method to doing the same thing.